The next speaker allows me to mention another name, not typically mentioned at MIT Imperial. Charles Fracchia here has a background from London as well, and he has spent a lot of time at various universities, including the Media Lab. He's going to talk to us today, I think, about another interesting trend that is perhaps best viewed by watching the movie Iron Man. So if you think about the Iron Man's or Tony Stark's lab, so this is kind of the fictional scientist with the biggest Twitter following at the moment is Tony Stark. But just think about some of the images that come into mind when you think about how how he interacts with his lab and brings out his Iron Man suit. And I'm just going to leave you with that thought and give the stage to Charles.
All right. There we go. So, hi everybody. I'm Charles Fracchia, and I'm the co-founder and CEO of BioBright. So, is that the clicker? Yes. So, it turns out that we have actually a major problem in biomedical research. We waste around $28 billion every year due to research that cannot be reproduced. That means you take an experiment from a publication or from a colleague, if you're in industry. You try to reproduce it. It doesn't work. It's so common that this number is actually quite large. If you read the publication that's listed down there, they actually estimate between $10 and $50 billion wasted every year. That's about $900 every second of the year, which is 24 hours a day. That number is also for the US alone, right? So it's a major issue, and it impacts biotechnology, it impacts pharma, ultimately it impacts our ability as a species to develop cures, right? And that is, in our assessment, many reasons are due to these two tools you see in front of you. These are like the cornerstone of biomedical research, the lab notebook and the timer. Well, the timer is pretty self-explanatory, and the lab notebook is to record information and observations, etc. Now, some people have said, okay, we're in 2016, we're going to move to electronic lab notebooks. But the reality is all that has done is replace the pen with a keyboard. It hasn't really fundamentally changed the way you think about biomedical research. And in fact, it's so much that researchers in the lab usually hate electronic lab notebooks because it's actually more cumbersome to use in the lab. Right? You just want to scribble a note when you see an observation. I'll show you a video of my friend Lisa. Lisa's very good at what she does. She's not that fast. This is a sped up video, right? What she's doing right here is combining colorless liquids filled with DNA together into a vial for her experiment. Now, assume that something goes wrong, which it happens all the time. This is a very manual process. Well, she has to stop what she's doing, take off her gloves, and write or type. And in the case of typing, she might have to go to a computer station to type her observation. So it completely interrupts her workflow. This is not really a way to go about things, not in this day and age. So what we did for this problem is that we built basically a voice assistant, much like the one that you use on your phone. So Siri or Google, but we've tailored it for biomedical research specifically. So
take a note that I used the blue stain.
Here's an example of our voice assistant that heard one of my employees, Jen, say, I used the blue stain. Simple observation. Records that information, and now it's kept in the record, time-stamped. We know when that happened. We know the context of this happening. We know who said it. We can even do all sorts of data analysis downstream. So we'll talk about that.
Darwin, show me primary incubation.
What I'm showing you here is the ability to even move around your workflow, right? And you've never taken your gloves off. You're always at the level of the experiment in your head. That's what you want the scientists to be spending their time doing. You don't want scientists to be involved in the minutia of like, oh, I used lot number MK573, right? And oh, I gotta take a picture of it or write it down. No, just Darwin, I used lot number MK753. That's it. The information is now in the system.
Darwin, take a note that we're getting low on Lamley buffer.
Now you're going to see a number of
Darwin.
different examples here.
This step is complete. Darwin, go to the next step. Darwin, which reagents do I need? Darwin, go to blotting preparation. Darwin, I ordered some more nitrocellulose transfer packs.
One more.
Darwin, I had to clean the transblot turbo cassette before beginning. Darwin, this LFP-VDF membrane had a lot of bubbles in it.
All right. So I don't know if you noticed there, but every keyword was correct. I don't know how many times you say LFP-VDF membrane in your life. Our clients say it all the time. But it was written correctly. And that's the power of Darwin over Siri or any other system, is that we are really tailored for these applications, where the vocabulary matters enormously, where the workflow matters enormously. Siri is tailored for ordering pizza and finding the latest sports scores, right? Not doing this kind of stuff. So, as Tron kindly mentioned at the beginning, this is what I want biology to be. I make no mistake, I was that guy on the left there. This is a very contemporary picture. People still work in laboratories this way. But Hollywood kind of sells us this idea that we can build these crazy labs and we're going to be enhanced by machines. You heard a lot about it today. Great examples. And the reality is that that's actually coming very, very, very fast. I showed you one part of that movie is a Jarvis voice assistant, Siri, etc. The voice assistant that allows you to reason about the experiment and be assisted by a artificially intelligent system around you. But what about that hologram, right? For those of you who don't know the movie, this is an excerpt from it. What you're seeing here is effectively, again, fiction, right? But somebody who's thinking about digital data in a physical space. Somebody who's like moving data sets and doing all sorts of Hollywood things that are not actually very realistic. But what you're seeing here is the merging of the digital data, which we collect now routinely in laboratories, with the physical space so that you can reason. Again, keep your brain where the experiment is. Well, yeah, so we built that too. Using augmented reality displays, you can actually show enhanced information right on the piece of equipment. So now the scientists can see, okay, I can get information from the digital world that is otherwise difficult to deal with today. Today, if you wanted to do that, often you'll see scientists print it out and paste it in their lab notebook. Okay, well, what if you want to change a little thing? Now you're adding a little note to that record. It has changed, and now it's not in sync anymore, right? What the company knows and what you know, that difference becomes enormous. That's what contributes to this enormous problem. Let me show you another example where you can combine both. Now you see an equipment, you see the information, and now you can add Darwin on top of this and say, actually, you know what? Darwin schedule calibration. I don't want to deal with all the minutia of like filling out 15 forms. The computer knows who I am, where I am, which pipette I'm looking at. Why isn't it doing everything for me? So that as a scientist, I can spend my time doing what is the added value that I bring to a pharma, biotech company. Show contents. So as you just saw, again, now you can have this enhanced information. You have the voice control at the same time. This is really kind of where the lab, where this kind of workflow is going. It's going there fast. So we are working with pharma companies, biotech companies. Here I mentioned the reason it's blank is this is being recorded. But some of our customers, we've shown deployment in a neuroscience lab, and we're improving the state of the art of that experiment by 20 times. First try, we think we can get 50. Right. We're 5 months in. Those are the kinds of improvements that you can see once you're blending the technology in a way that is assistive to the human, where you're conversing and you are centering the human on what their added value really is. So one last thought is that with diseases that we see now, with a faster and faster pace of the emergence of these diseases, my argument is that we can't really afford not to do that. Thanks.